GATE 2015 Civil Engineering Set 1 Question 41. A non-homogeneous soil deposit consists of a silt layer sandwiched between a fine sand layer at the top and a clay layer at the bottom. Permeability of the silt layer is 10 times the permeability of the clay layer and 1/10 of the permeability of the sand layer. Thickness of the silt layer is 2 times the thickness of the sand layer and 2/3 of the thickness of the clay layer. The ratio of equivalent horizontal and equivalent vertical permeability of the deposit is. The relevant NPTEL reference has been listed. So, when we need to find equivalent permeability, two cases are possible. The first case is that the flow is happening parallel to the soil layer, and the other case where the flow is happening perpendicular to the soil layer. So, in the first case where flow is parallel to soil layers, let us assume 3 layers of the soil whose thicknesses are T1, T2 and T3, and their permeabilities are K1, K2 and K3. So in this case flow is happening parallel to the soil layers. So the equivalent permeability in the horizontal direction would be equal to summation of Ki Ti divided by summation of Ti. Here I will vary from 1 to 3 since there are 3 layers. In the second case, when flow is perpendicular to the soil layers, let us assume a similar case with 3 soil layers K1, K2, K3 of thicknesses T1, T2 and T3. Here the flow is happening in a vertical direction and perpendicular to the soil layers. So the equivalent permeability in the vertical direction would be equal to summation of the thicknesses divided by summation of the ratios of thicknesses to the individual permeabilities. So this formula can be extended up to n number of layers, but in this case it is 1 to 3 since there are 3 layers. So coming to the solution, we have 3 layers in which the first layer is of sand, the middle layer is made up of silt and the third layer is of clay. It is given that the silt layer has 10 times the permeability of the clay layer. So let us assume the clay layer to have a permeability of K. So silt will have 10K and sand would be 10 times of silt, that is 100K. The thickness of clay layer would be 3T and 2/3 of this would be the silt layer, so that is 2T, and sand would be half of the silt layer, that is T. So horizontal permeability equivalent would be equal to summation Ti Ki divided by summation Ti. Here I will vary from 1 to 3 since there are 3 layers. So this would be 100K into T for the sand layer, 10K into 2T for the silt layer and 3T into K for the clay layer divided by the sum of the thicknesses, that is T plus 2T plus 3T. This would become 123K T by 6T. This would become 123K over 6, that is 20.5K. This is our first equation. Next we will find the vertical permeability equivalent. So that would be summation of the thicknesses divided by the summation of the ratio of thicknesses to the permeabilities. So this would be T plus 2T plus 3T divided by T over 100K plus 2T over 10K plus 3T over K. So using this, the value would come out to be 6K divided by 3.21. This would be 1.87 times of K, that is our second equation. So we are supposed to find the ratio of KH over KV. So KH was found out as 20.5K and KV was found as 1.87K. So this would become 10.967, which can be rounded off to 10.97 or even 11. So the ratio of equivalent horizontal and equivalent vertical permeability of the deposit is 10.97. The relevant NPTEL reference has been listed.